So when you looked at IP addresses, you would have found that a V4 IP address has those four numbers, actually going from 0 to 255 each. And if you calculate the amount of possibilities that gives us, you find it's about 4 and a bit billion different combinations, which has a big limitation straight away. Actually, there aren't enough, and you probably looked at that when you saw IP addresses or V4 addresses at least. And one way we can solve that is by having two types of IP address or two types of V4 IP address, and they're often called routable or non-routable, or often public or private addresses. And they work a bit like this: that inside a home network, and your network inside your house will work in a really similar way. You'll probably notice that if you've looked at the IP addresses, they're all very similar. And if you went to a friend's house or anything like that, and you looked at their IP address, they're going to be very similar again. And that's because there have been certain ranges of IP addresses have been reserved as private addresses. And those ranges are always ones that start 192.168.something.something or 10 dot something dot something dot something. So if you see any addresses that have those kind of patterns, we know they are private or non-routable addresses. So what we mean by that is that you cannot directly route to one of those addresses, hence why they are known as private. Now on my diagram here, I've got three examples of private or non-routable addresses. So these C's and the R could represent a small home network, for instance, with a couple of computers on it or something like that. The R is the router for this computer. And notice how it has two addresses. So we have both maybe like an internal address, you could think of it like that, but it's fundamentally a non-routable address for that router that it would be using on the home network side of that sort of arrangement. And it also has a routable address. Now, if you were to send data to this network, so let's say they were requesting something off the server on this diagram, so the S, then data could be sent to the routable address, and then that router would do the job of sending that on to the non-routable addresses. And the same if we were sending stuff out, the router would do the job of sending stuff to the server using the server's routable address. Now, that has a couple of advantages. One is it solves that problem that we don't have enough IP addresses for all devices. If every device connects to the internet at a routable address, we would very quickly run out and they would no longer be unique. It also acts as a bit of protection for these devices that have private addresses, because these two computers in this home network cannot be directly accessed. They cannot be directly routed to. So it acts as a little bit of a barrier in that respect as well.